Welcome everybody to this panel discussion. It's the first panel discussion on the time series analysis. So I'm here with Professor Daniele Tonini from the Università Bocconi in Milano. He has a lot of experience on time series analysis, on statistics, so he's on machine learning. He's the perfect panelist for this kind of event. Then we have Corey Weisinger. He's a data scientist in the Evangelism team at Knime, and he is the one who works with signal processing and numeric prediction techniques for time series analysis. By the way, he's also the author of the Alteryx to Knime guidebook. And then we have Maarit Widmann, and she's a data scientist, and she's also an evangelist at Knime. She has a master's science in economy from Konstanz University, and she's our person behind the evaluation techniques in machine learning. So why do we have them here? The three of them are the group behind the components on time series analysis for Knime Analytics platform. So you can see here there is a little screenshot of the Knime Explorer, and you can see here the components for the time series analysis in the example server. They have also organized the previous webinar on time series analysis workshop on April 23rd. They are the authors of the Building a Time Series Analytics analysis application, where they explain step by step how to proceed to build a time series analysis application. And then, of course, they are the teachers of the course Introduction to Time Series Analysis. The next one is on July 20th. So I finished with the introduction. We can start already with the questions. We have preloaded some of the questions that have been asked at the moment of at the registration. Anyway, if you have your own question, please use the Q&A button here at the bottom of your Zoom link. And if you see the questions and you see one question that you like the most, you can upvote them using this thumb up here. The session is going to be recorded. It will be available on YouTube, so don't worry. We will send around the link to the registered people, the link for the YouTube recording. Okay, so let's start with the question and answers. Okay, so are you ready?
Ready. Hello, everybody.
Okay, so my first question is, the first question comes from me. Why is there so little educational material on time series analysis? So we have been trying to put together this course, and we thought maybe there is already something around, but it's really hard to find a course and educational material on time series analysis. And why is it so confused when there is? I think this is for Daniele.
Yeah, okay, thank you, Rosaria. Well, first consider that time series analysis it's not a new topic, and it's not also a fashionable topic in the last few years. So in the last few years, everybody knows that there is machine learning, deep learning, natural language processing. Time series analysis, as you said, maybe it's not so common in the last few years, and we have a few educational courses around. So it's a topic, time series analysis, that was deeply analyzed and developed during the last century, and where we have for a long time now many reliable methods for analyzing time series and to produce good forecast. So it's a pretty consistent subject. And so if you are an experienced practitioner in business forecasting, you know pretty well what to do in this area with your data and how to produce some forecast. And so maybe, to reply to your question, maybe because time series analysis, it's something that is really rooted and well known for a lot of people, and also because in the last 10 years there's been other more popular topics. There's a general less focus in the data science courses, both online and offline, on time series data. This is true also in my university, that you can find many maybe data science courses, but not many time series analysis courses. And it's pretty easy to see it also if you look into the online, to the data science examples, applications, and competitions. I will say that maybe 95% of those ones are focused on normal cross-sectional data, and maybe just 5% of them are focused on time series data. So I think that's why, maybe, and also because time series, it is something that can be pretty complicated because it's you need statistical methods, you need some machine learning methods, signal processing methods. So you need many different domains of knowledge. I have to say, to conclude, that recently, just the last few years, 1-2 years, there is a rising interest on time series topic because many new generation of data scientists feel themselves maybe lacking a bit on this important topic, and also because there are some new interesting development in the time series world regarding maybe how to connect machine learning approaches with classical time series approaches.
There is a related question. What is the difference between time series and forecasting, time series analysis and forecasting?
Forecasting, it is just one possible application of time series analysis. So it is maybe the most important application of time series analysis because, of course, if you have a time series, you want to forecast in the future your time series, but it's not just forecasting time series analysis. So maybe also the descriptive analysis of a time series could be something interesting, and it is something that you have to consider differently from a typical visualization and descriptive analysis of cross-sectional data, so of normal data. So time series analysis, it's not just forecasting, it is also descriptive analytics, simulation, and it's also other kind of possible analytics, and the forecasting, it is the main application of time series analysis.
So, but then my next question is that why you created your own time series analysis course? Maarit?
Yeah, I can say to this that, so we also realized this need for learning materials about the theory of time series analysis. And this is what we also introduce in the time series course that we provide. But on the other side, we now many Knime users, they would like to do time series analysis. They would like to train an ARIMA model or other types of tasks that are specific to time series analysis, but it was not that easy in Knime platform. And how we solved this, we created components. And if you're not familiar with components, they are like Knime nodes, but they are built with a workflow instead of a code like the individual nodes.
And where can I find them?
You can find the components on the Knime Hub. So if you type there search term time series, and then you filter the search results to components, you will find a number of time series components. And we also introduce all of these components in the time series course and build example tasks using them.
And examples where I can find them too.
Example workflows. If you, again, go to Knime Hub, you can find the workflows that are the exercise workflows that we use in the Knime course. And then since we produce more and more materials like the blog posts, and we have more and more users, time series users in Knime, many of these workflows are also available on the Knime Hub. So in the search results, you just filter the workflows and find these there.
So here there is a question. It asks, are there more in detail reading sources that you know of? Books, or I guess books.
This
books,
is maybe
yes.
a more...
There are a lot of them. Okay, go Maarit, please.
No, I was just saying maybe you are a better reference for this.
Okay.
Everybody contact your bookshelf.
There are a lot of interesting books. There is that they are gold standard of time series analysis. Then, if you want, I can share the links. In my opinion, the best reference if you want to start with this topic is the Professor Widmann online book on time series forecasting, and it's called Forecasting Principle and Practice, I think. This is the title. And this is, I think, one of the best reference. But then you have other good books on time series forecasting that you can use.
So there is another question coming in. It has been waiting for a while. So given that we are in a black swan time period, when looking at forecasting, what does time series analysis give us to build forecasting to the future? I think it means that given that everything has changed now, how can we build on a past that we don't have?
Hot topic this year.
Yeah.
Yes, it's not topic. I will say that typically when you have this kind of structural breaks, so when everything is changing and the conditions of the markets, of the macroeconomics, they are changing a lot. It's a difficult task to use time series models and forecasting. It's pretty risky, I think, because everything has changed and your model have some difficult maybe to learn some patterns in this particular period. So in my opinion, I won't do any forecast now and just wait for the maybe new data and to say what happens now. I don't know. I don't have an answer here. My opinion is that you can find a lot of forecasts over there around the internet about what's going on from now up to the next 1 month, 6 months. But I won't trust a lot on this particular forecast made on this specific topic. It's really risky because we are experiencing a really important structural breaks.
Okay, so we got the question that we always get. So be prepared. So what shall I use? Which family of models is best to use for time series analysis? ARIMA, machine learning based models, or LSTM based recurrent neural networks? I guess we have talked about that a lot. So I guess Daniele has the best summary.
Yeah, so yes, it's a popular question, but also a difficult one, just because in my opinion, there's no answer. So all the models and algorithms, they have their own pros and cons. So, okay, in general, classical methods, just like exponential smoothing, ARIMA, and other methodologies, they have been around the longest. They are easy to implement and typically very reliable, but they require to verify some assumptions, and sometimes they are not as flexible as you would like them to be. Okay. Machine learning models, on the opposite, they are really flexible because you can include many variables in a multivariate fashion, and you don't need to check assumptions, basically. But commonly, you need a large amount of data to train them properly. And they can be more complicated, so a lot of hyperparameters to tune, and to be effective, you need to create some extra temporal features to catch the time-related dynamics of your data, just to catch complex seasonality and trend patterns. So pros and cons of each algorithm. But an important thing here to reply to this popular question, what is the best model? And as we are going to explain in the forthcoming time series course next week, it is not just about the performance comparison. So when you have to state, okay, this is the best model in this case, don't just look to your error metrics. You need to consider many other important items in your model selection procedure. So for instance, the forecast horizon in relationship with your goal. So sometimes if you want to predict short term, there are some methods that are better than other methods. But for the same time series, a short-term prediction could have one best model, and for a long-term prediction, you should change the model and use another one because it's better for a long-term prediction. So you have to consider also the forecast horizon. And you have to consider also the type and the amount of data that you have. You have a small data set made of few observations. Okay, maybe in this case, it's better to use a classical algorithm. Or if you have a very huge data set with a lot of observation, okay, in this case, you can use a machine learning one. Another thing is, do you require to interpret your model? So you need to interpret the relationship between, maybe if you have a multivariate approach, you need to interpret the relationship between your dependent variable and your predictors. In this case, maybe a classical autoregressive approach, it's better than a machine learning approach. Then you have to evaluate the number of time series that you have. You have to evaluate also some deployment issues of your models. So there's a lot of items that you need to check, not just the model performance. That's why it's difficult to say which is the best model. It depends on your analytical application. It depends on the data that you have. So basically, try different approaches, considering your goals, considering your data, and try to find out what is more suitable for you.
There is a second part to this question that actually links to a question that we had during registration. So this is for Corey. Are the components for time series analysis based on the integration with some special libraries? And the second part of the question here is, can I incorporate the Prophet into Knime?
Yeah, so Prophet's become really popular this year, in particular because of a lot of the automated tools that it brings to the table for decomposing a signal and kind of extracting some patterns from it before pursuing the modeling at the end of the package, I suppose. But our components that we have in Knime currently are largely applying functions from the stats models package, as well as some more general functionality from NumPy and Pandas. But yeah, we've been considering adding components for Prophet. It's not something we've started yet, but it would be something really cool to see from the community and pop up on the hub too. Because right now, how you would use Prophet in Knime is presumably through a Python script or whatever language you choose. But that could always be wrapped up into a component, kind of like some of the time series components that you'll see that we've posted. You could add some external configuration on the Knime side to control it like we have. And that would be a really easy way to integrate Prophet into your Knime workflow, share it with some colleagues.
But the current time series components, are they based on some external libraries?
Yep. So they're using largely stats models in Python. Yep.
Okay. Okay, there is another question that was asked also at registration. So if I decide to use an ARIMA model, how can I pick the values for the 3 parameters of ARIMA for the best forecast result? This is for Maarit, I guess. And now here also ask something similar.
Okay, so ARIMA model is a regression-like model that considers the past values and past residuals as regressors. But when we build this ARIMA model, the question is often how many past values we consider, and these are then the AR and MA orders in the model. And it's not always easy to say what is the right value for these orders. So what we can do, which we also have a section in the course, we can inspect the autocorrelation plots and partial autocorrelation plots of the series. And then from the decay or some major spikes in these plots, we can say this is the right AR or MA order for the model. But often the time series, it's not that well structured or following such a clear pattern, that we just need to take the best fitting AR and MA orders. And this is possible, for example, with the auto ARIMA component in Knime, where you just give the maximum orders, like for example, ARIMA 212 model. And this component trains all possible combinations of these parameters starting from AR1 and outputs the best one.
There is another question. So for each one of you, but you can decide, maybe Daniele can answer. What are the most interesting recent developments in time series analysis?
I would say, from my perspective, of course, it's the integration of machine learning methods with classical time series methods, because the benefit of using classical time series is that they can deal directly with time component part or time component dynamics of the time series data. So you can analyze pretty effectively the seasonality, the trend, using classical time series data. Using machine learning approaches, sometimes it's not so straightforward to include this time component dynamics. So the integration of these two big areas, these two approaches, it's pretty cool. And another thing is how to use deep learning for time series data, because, you know, I spot also another question, maybe that is connected with this one. There is someone, George, that asked about one-dimension CNN and LSTM. This is another interesting thing. So how to use convolutional neural networks that, you know, typically they are used to analyze image data. But if you use a one-dimensional convolutional neural network, and typically the dilated convolutional neural network, you can extract some temporal feature from the data in an effective way, and then you can feed those features into an LSTM layer. Also, this kind of approaches, so how to use the typical deep learning approaches in time series data, I would say is a pretty interesting approach. So there's a lot of things that are boiling and that, in my opinion, are pretty interesting. And I think they are mostly related with the machine learning and deep learning.
Okay, so we have another question that also was asked during registration. So the question in registration, which is similar to this one, is how much past is enough past? So how much do I need to go back in the past to produce an acceptable performance in forecasting? So here is the same, is asking how much many data must be for the time series analysis, 50 past samples, 50 or more. So how much past is enough past?
Okay, I can answer, because also this one is pretty popular question. So also here, just like the question about the best model, I don't have a straightforward or a simple answer. So the general rule is, of course, use all the data that you have, but always consider possible structural breaks in your data and important changing in the phenomena that you are analyzing. Sometimes it's better and more clean to get rid of uncommon period of time than including those periods in the data set. So there are some techniques to modeling breaks and changing in your data, but sometimes, okay, I use, if I want to use 5 years of data, and I see that 5 years ago something strange happened, you can say, all right, let's get rid of that year and just use last 4 years of data. Maybe you will obtain better result. Another best practice is to carefully analyze the seasonality of your time series and use an amount of past that is effectively that effectively estimate the seasonal component in your data. For instance, typically for a classical time series approach, it's better to include 4 full seasonal cycles in the data. So if you are analyzing monthly data, for instance, consider at least 4 full years of data. So again, here it's a trade-off. Sometimes you don't need to use very, very long time series to obtain an effective model, but try to include an amount of past that is able to make your model detect all that important temporal feature. So use a past that it is able to detect correctly the seasonality, the autocorrelation, the trend, and all the important dynamics.
There is another question. This is for Maarit. A class of problems such as economic modeling deals with stock and flows. The challenge is that stock integrate over time, accumulates and deplete. So what does Knime offer? now and in the future to deal with this problem? Are there plans to integrate with tools for stock and flow consistent modeling?
What I know about the economic models is that many of them just evolved from the time series models that we are handling in the course. For example, these more basic ones, and in many other tools, the economic models are specific packages. And unfortunately, in Knime, we don't have these economic models yet available as components, for example. But what we have is what is common pre-processing. For example, stock market data is that you make it stationary by taking the returns or considering the returns instead of the asset prices, or you make log returns, or you calculate multi-period log returns. And for these tasks that I mentioned, we have components for that. So that is the beginning for the economic modeling in Knime platform.
Nice. So the second question then, what sort of other case studies of time series are there? Corey, maybe you want to answer this one?
Yeah, so I feel like this kind of builds on top of the earlier question about time series and forecasting. Yeah, so some other common use cases I've seen that I'd arguably toss into the time series category are stuff like machine maintenance, perhaps, or just survival analysis in general. So maybe you have some time series of sensor data on an engine, and you're analyzing it to predict some kind of classification features opposed to some kind of forecast, and that could be how likely the engine is to break soon. So there's different, that one comes up a lot in some factory settings, as well as on big expensive machines like windmills and stuff like that. Other things you might see for time series use cases are like voice recognition. So that's ultimately a series of probably timestamped data coming into some kind of machine learning application that's trying to either convert it into text or convert it into some kind of command for the computer to run after the model's finished. So those are some common applications for time series or signal data.
So there is another one. So this one, we don't have a lot of time, so we have to do it very quickly. Somebody's asking how if you can elaborate the mechanism of the time series with Knime. So basically, the data flow that you would use to run a time series analysis project. That's basically your previous webinar. So try to make it in just 2 minutes. Is somebody up to the challenge of summarizing 1 hour
that
webinar?
We posted or mentioned at the beginning of the webinar would be really helpful here, I think. So that would be a good one to check out, is just kind of read through that article, and that'll kind of summarize it really quickly. But I guess to put it in short terms, a lot of what we're doing initially is kind of pulling in some data set that is our time series data. Maybe that's row by row timestamped data. Maybe it's just a column of numbers, something like that. Usually we're going through there to do some just standard cleaning up of it. Maybe we're checking to see if there's any missing timestamps, fixing missing values, things like that. Just standard clean it up, make sure it's nice even time series for future use. We're putting it through some signal decomposition usually, analyzing it that way. We'll take a look at things like the ACF, the PACF plots, and that's something we'd get into more detail in the time series course. And that came up a little bit earlier as well when we were talking about using the ARIMA model. How do you choose what different degrees you should use inside that model? What should my AR value be? What should my MA value be? Stuff like that. And that's stuff that we would explore using those graphs, and then kind of go through model, maybe generate some forecasts, play with your model metrics, look at different forecast horizons, and kind of just start playing with it and see what you actually need as a business case.
Perfect. That was a 2-minute summary. So next question, I think, is still for you, Corey. Is it possible to use signal processing in Knime? And there was a previous question, how can I generate frequency-based time series with Knime?
Yeah, so there's a little bit of signal processing available in Knime. We have support for the discrete Fourier transform as well as the discrete wavelet transform, both of those through components. And there's also a partner node for the DFT as well. So you could play around with both of those and see which one you like the best. So those give you options for transforming some kind of signal, so maybe just some high frequency time series data basically, and turn that into some kind of frequency domain. So we can do that with the DFT, and you'll have different tamping windows through that. You'll be able to choose kind of the size of those windows. And then we also have the DWT, which will give you the options to choose those window sizes as well. And there's a ton of different wavelet options to choose from in there. And you could go through, use that for some filtering. You could use that to build some features to build a classification model on. So those are kind of the support that we have for signal analysis. Then we also plug into Kafka, for example. So there's different ways to access that as well.
There is one question that came up in the registration as well. So what do I do if I have a very small data set with not much history? Are there any techniques that you can recommend?
That's always a tricky one, right? You'll see that maybe somebody's trying to actually go through and use our decompose signal component and then plug it into the ARIMA and try to generate forecasts that way when they're looking at maybe 2 weeks of data and they've only got 100 rows of information. And really in these kinds of cases, you don't have enough information to build those kinds of more complex models to go through and find those patterns, because as Daniela was saying earlier, you should really have several iterations of a pattern before you start trying to extract that seasonal history. So in those kinds of simpler cases, I think it's important to just kind of keep your prediction method as simple as possible. You could try something like a basic linear regression, a naive forecast just using the previous value, maybe a mean estimation, or just try to keep it simple there and understand that to get into these more complicated ML applications, you'll need more data.
Yeah, if I can add something, don't underestimate, as Corey said, don't underestimate power of simple model in time series analysis, because I think it's more true in time series analysis than the cross-sectional data. That very simple model, just like naive or seasonal naive, sometimes they can beat any more complex algorithm easily. So when you have a few data, very short time series, just go with the very simple methods, and typically this is the best thing that you can do.
So there is another question. It says, would it help to describe a special situation for the COVID situation in the time series using 0 for normal and 1 for COVID, for example?
When I think of trying to solve this, and this isn't something that I've actually gone through and tried with COVID in particular, so I don't want to necessarily promise anything, but when I think of trying to solve for the data problem with COVID, I think of trying some different transfer learning techniques, for example. I don't know if marking with like a classification feature like that, a class feature, would particularly help in the training of that model. Maybe Daniela wants to correct me on that, but what I would try is something more like transfer learning, where maybe you take a model and train it on your past data and just kind of tune it on current information from everybody staying at home. Maybe you have past data from online sales and you start there, and then you just tune it on more recent stuff where everybody's at home and shopping online more. That's would be my approach at trying to make it work. But yeah, there's a lot of different options, and as we were saying earlier, it can be difficult to forecast it all right now. So
yeah.
There is a request for Maarit for the next course, but I think I'll just pass it to Maarit, and she can take the request. Yeah. So there is another question about a practical question. Given a time series, what is the best approach for automatically splitting a data set into training, validation, and test portions, so that the validation and the test portions include all the periods, seasonality present in the training portion? There was another question in the registrations that said, how can I avoid data leakage in when preparing the data to train a time series analysis model?
So when we're talking about data leakage with time series, I think those kind of overlap a lot, and I'm guessing that's why Rosaria asked them together. When we're talking about applying things correctly from the training set to our deployment workflow or to our test set or whatever that happens to be. And Knime's got a lot of tools for solving that, especially today with our new release coming out. So the problem with data leakage in time series is usually if we do some large level like processing of our data, maybe we subtract the mean value or something. If we do that before splitting our data, then we kind of skew it. We get that data leakage if we do any processing on the set before we split it into training and testing. So it's important to make sure that you split up your data, do all of your pre-processing, your cleaning. Maybe that means using our decomposed signal component, and then apply that later to your test set in the deployment stage. That way you're not using any information from that test set to generate its pre-processing steps. And ways to do that in Knime, there's a lot of nodes that have the apply keyword at the end of them. For example, the missing value node has a missing value apply node that goes with it. And what this one will do is it'll let you plug it back in to the original node, and it will run the same process that was learned from the earlier nodes. For example, if you're filling missing values in your training set, you could fill them with the mean value, right? And then when we apply that to our deployment section of our workflow, we'll be using the mean value from the training set. And that's important to do because otherwise we could get some data leakage in there if we fill those before splitting the data, because then we'd know that the trending is going upward just from already seeing the future data set. So that you have to be very careful with where you generate the pre-processing steps and make sure that you do them after the data split.
Another question was how to use the partitioning data so that data leakage is avoided. I don't know, Maarit or Corey?
So in this case, the data leakage would mean that you have a training set that has future and past values from the point of view of the test set. So you break the temporal structure in the data. And this is not what we want to do when we train a time series model. How you avoid that? There is a partitioning node that you use to split the data into training and test sets. And there is the option take from top. And since the data that you're using for this training, it's ordered by time. And if you take from top for training, then you keep the temporal structure and this data leakage doesn't happen.
So another related question is, where do I have the optimal cut between validation, testing set to capture enough cycles? Can I, without plotting them, can I find the optimal cut?
What you could do, for example, if you have data for multiple years, you cut the last year as your test set so that you have one full year, so that you don't, for example, exclude all the Christmas time if it's some sales data, or you don't exclude the summertime if it's some sales data. Of course, it depends on the type of the data that you have. If it's in millisecond granularity, of course, you don't take 1 year as a test set.
I think it's also the seasonality index, right? If we want to find the seasonality, we can use the component, and then we get the seasonality index, and that's the span.
Exactly, yeah.
Yes, it's really important to consider seasonality when you have to select the test set and the training set, absolutely.
Okay. So there was one question that was at registration. It said, do I need to decompose the signal before training the model, talking about seasonality? And if yes, if I need to decompose the signal, why? How to separate seasonality and trend from the signal? Daniele, maybe. Corey, okay.
Corey.
So I'm just always quick to talk whenever there's a silent period. Yeah, so decomposing the signal is definitely a recommended step, but you have to bring some of your domain knowledge into these things, right? For example, the series we use in the time series course is based on electricity consumption. This is something that we know is going to have very strong seasonal patterns. I always have my air conditioning on maybe in the evening, but maybe not overnight. I have the lights on at the office at work during the day. So there's very strong patterns to when these are here. And given that we know that, we really want to be able to go in and look for those seasonal patterns kind of concisely and pull them out, because we know that'll help our model be more accurate in the future. And again, it depends on the kind of model you're using. If you're using the ARIMA model, then a lot of these steps are going to be mandatory to satisfy some of its assumptions, like the stationarity. If you're using something like the LSTM network for deep learning, one of the cool things about deep learning in general is that it can do a lot of this feature extraction on its own. So you are able to run that LSTM network on the raw data set. Not necessarily that you'd want to. You should still look into doing that signal decomposition, because then we can use the ML approach just to model kind of those residuals after we pull out the, I don't want to say obvious, but obvious patterns there. For example, the weekly cycles. And then once we kind of compile the actual seasonal pattern and our ML approach at the end, we'd have hopefully the most accurate model we could come up with. So it's important to decompose that signal so that we can point our ML model at the part that we don't understand intuitively.
There is one question I think is for Daniele. We were talking about that before. Did you follow the recent forecasting competition M5, and do you have any thoughts on the result and approach taken by the participants?
Yes, I follow the competition. I'm actually reading now the solution of the participant. So I think it was a pretty cool competition. And the idea of this competition was to exploit some common belief about time series data, pretty recent beliefs, because if I think about this research paper of 2 years ago, I think in this very famous paper, we have this result that typically, for most of the application, classical time series analysis with the ARIMA and exponential smoothing, they are still the best in class for general purpose time series analysis. No, so in this competition, they want to say, okay, is there maybe a situation where machine learning approach can effectively be better than ARIMA or classical time series analysis? And the answer is definitely yes. So where you have a lot of data. And here I'm not talking about the number of observations. Of course, I'm not talking about that the time series is huge because you have a lot of observation. Here I'm talking about a data set with a lot of time series to forecast together. And here in this competition, we have 40,000 time series to forecast all together. And they are also hierarchical. So it's pretty difficult situation. In this case, machine learning methods can be more effective because you develop your list of relevant features for all the time series, all the 40K time series, and then you train your ML model, tuning the hyperparameter in the proper way, okay? With a classical approach here that is more tailor-made, more time-consuming, it is pretty difficult to do it for 4,000 time series. So you don't have to look at the time plot, ACF, make an assumption. So it's more convenient here to use an ML approach. And actually, if you see the result of the competition, the winners, they used mainly gradient boosting machine using the light GBM library. So I think that the first position, so the winner, and the second place, it was using light GBM. And pretty interesting, the third place, it was a guy or a team where they use a deep learning artificial neural network approach using LSTM. So in this case, when you have a huge data set, a lot of time series, it is more convenient and it's more effective to use a machine learning approach with gradient boosting or deep learning like LSTM. Okay, so pretty interesting results.
Okay, we have time for a few more questions. So then we need to. So the next question is, what time series prediction model do you think would be best to capture outliers? What pre-processing steps and practices would you suggest for highly volatile data? 2 questions. Outliers.
So I think when we're talking about outliers, it's important to kind of pull in some of your domain expertise and really think about what the business use case is here, because it really depends on the situation, right? If you are suspicious of those outliers being like false data points, then perhaps replacing them with either a previous value, an imputated value of some sort, or even removing them could be useful. But if they're just really high values, maybe it's important to think what's important when you're actually generating these predictions and these forecasts. Do you need to identify these spikes? Do you need to generate, just in general, accurate forecasts? Do you care if you're occasionally off by way more than you'd expect? Is that a big deal? And I think it's important to keep those things in mind, because there are options to kind of reduce the size of outliers like that. You could do things like logging of your series to kind of bring things down into a tighter band. You could do some aggregation on your time series. If you had maybe hourly data before and you didn't need it that finely grained, you could aggregate it down to the day level and you'd see far fewer outliers. So it really depends on your use case and what ultimately business needs at the end of the day, and what your domain expertise tells you about those outliers beforehand as well.
And pre-processing for volatile data?
I can maybe say one word about this because this was also requested for the course. So this clustering of the data, there we find, if you find a data that is really unstructured and you cannot find there a pattern that you could model somehow, sometimes clustering data into one time series into multiple time series that show more regular behavior could solve the problem. And this is also how this kind of data we handle in the time series course in the exercises. And I'm happy to show how the clustering is done as a supplementary material in the course as it was requested. Yeah.
Okay, let's take one more question. If I have a large time series data set and I would like to deploy a trained model into a database, to score my model right in the database against the data, what would be the top 2-3 database to do this?
Anybody have a favorite?
Yeah. So let's say, yeah, Daniele.
I'm not familiar with this topic, sorry, about the database.
Let's say that we discuss about how to do it with Knime, and the Knime components, we are not familiar with the database, different capabilities.
It's a more data engineer topic, maybe.
Yeah, on how to do them.
What I know, there are specific databases made for time series analysis. I don't remember the name, actually. You can search on the internet. But yeah, I don't.
We can deploy them in Knime as well. So, okay, so let's choose the last one, and then we will close. So the last two, an easy one and a more complex one. Let's start with the complex one. One challenge of traditional time series analysis is that it tries to predict future based on past occurrences and pattern. Whereas in complex systems, the behavior of the system and the resulting time series values are generated by the structure of the system. Therefore, how can Knime be used today to connect to other models, for example, system dynamics or agent-based models, and run these models within Knime, and B, to connect to real-world data, which are pulled into these structural models? So that's a bit of a complicated question. So how to integrate external models and how to connect to real world data?
Well, when we start talking about integrating external models, it depends on what kind of model it is, right? So if it's a PMML model that we can just load into Knime and run right inside of the Knime interface, then of course that's straightforward enough. If it's a deep learning model, we can read in several different formats. But if it's something more obscure or just something that we don't have reader support for, then the most direct approach would probably be accessing it through a scripting node. So for example, you could access it with Python if it's a Python code block, Java, R, etc. And then of course we've got support for REST APIs, for example. So if you're trying to pull in weather data, maybe you can just hit some weather.com REST API or something like that. Same thing being true for getting web-based models. If you can access them through that, then that's also a great way to plug into external tools.
And to connect to real-world data?
Yeah, so I guess that depends on what real-world data means in your context. If it's something that can be pulled from a REST API, maybe it's yesterday's stock values, maybe it's the weather this morning, then that's an easy way to do it. There's plenty of APIs like that available online that you can connect to. If it's something like a sensor that you've got outside in your backyard, then we have different support for that, not directly, but through some integrations like Kafka, for example, could help you plug into external sensors.
Okay, so next question is, are there any nodes for Instagram and Facebook API, just like Twitter? And how long into the future can you depend on your time series analysis? So, Maarit, nodes for Instagram and Facebook API, like Twitter API?
This one, I have to say, not that I know, maybe if anyone has other information, please correct. And on this second question, you can improve the performance of your future predictions by dynamic deployment, which means that you forecast values in the near future and use these forecasted values to predict values further in the future. But of course, how far in the future you can predict depends on how regular the dynamics in your time series is. And but this doesn't help until infinity. At some point, the forecast accuracy stabilizes to a constant value. And when this happens depends on the data that you have and on the model that you have.
Okay.
You need to monitor the situation. So you need to monitor the accuracy of your models and understand if there is some kind of drift in the performance. And of course, when you see some poor performances or they start to drift off the goodness, you have to retrain maybe or to re-estimate your models.
Okay, I think we have to stop here. Now, I don't know if you all noticed the t-shirt of Corey. Corey had a fantastic t-shirt, and this is the release t-shirt that we received today, because today there was the new release for the Knime Analytics Platform 4.2 and the Knime Server 4.11. There are a number of fantastic new features, a lot of new connector nodes for the ones who were asking before. We are going to have multiple spaces for sharing new profiles on the Knime Hub and the TensorFlow 2 integration. So a lot of nice features for Knime users. And we have also a lot of nice features for the enterprise, the integrated deployment for an easy and safer deployment. Elastic scaling, hybrid deployments, metadata mapping, and guided automation. Please don't miss it. And all these features will be explained in the webinar on July 21st. It's going to run twice, 1:30 for the Central European time and 1:30 then for the Central American time. Thank you, all of you, for staying with us until the end. Thank you for the many questions. It was very interesting to answer all of them and to bring some clarity, to hear some clarifications about the topic of time series analysis. Thank you very much. And we hope we will see you at the What's New webinar on July 21st.